Alright, let's look at the homework 5.3, problem number 10. Alright, so we're going to look at this as the limit of the Riemann sum, so that we can rewrite it as a definite integral. Then we can evaluate from there. Alright, so let's do that. So we have this is equal to limit as n approaches infinity. Right? So it looks like this guy is going to be the delta x, right? So I'm going to put it at the end. So you have, let's see, I'm going to put it right here. 16 over n, right? Then we have a bunch of additions. So this is going to be a summation. And I goes from 1 to n. Right? So it looks like this is a square root of 16 over n times 1, and this is 32 is 16 times 2, so it looks like this is going to be a square root of 16 over n I. Right? So you can see that this guy is our delta x. Right? This guy is our xi. Right? So we know that this is going to be, so if you write it as, right, limit sum is the same thing as the integral, right? Interval is from 0 to 16, so you have to go from 0 to 16. Alright, so this is a square root of xi, so function is square root of x, right? Then here, delta x can be written as dx, right? Then we can evaluate this integral. So I don't like square root, so I'm going to rewrite it as x to the 1/2 power. All right, antiderivative would be, all right, add 1 to the power, so it's going to be 1/2 plus 1, so 3/2. Divide by 3/2 is equivalent to multiply by 2/3, so I'm going to put the 2/3 there. And then you're going from 0 to 16. So I'm using a fundamental theorem of calculus part 2. Alright, then plug it in. So you're going to have, right, so plug in 16. 16 to the 1/2 power would be 4, because it's square root of 16. And then you have to raise it to the 3rd power. Right, so that's, let's see, 4 times 4 is 16. 16 times 4 is 64. So you have 2/3 times 64 minus, plug in 0. It's 0 anyway. So this is going to be 128 over 3. Right? Alright, so let's type it in. So we got the 128 over 3. Alright, so let's check submit for testing. Alright, it came back and looks like we got this one correctly. Alright, that's it. I hope that this was clear.